So the first one we look at for the introduction of acid-base titration. So the acid-base titration can be defined as the process of adding of standard solution of an acid or base to a solution of unknown concentration until the neutralization occurs, allowing the concentration of the unknown solution to be calculated. So there are few purposes of acid-base titration that happen. Why acid-base titration happen? So the first one is determine the concentration of an acid or base, and then determine the amount of a substance in the sample, analyze the purity of the chemical, and the lastly is the monitor chemical reaction in laboratories and industries. So we look at for a simple definition for neutralization process. So neutralization occurs when an acid react with a base to produce salt and water. Or we can see for the it's like for more to balance the acid and base concentration. So the hydrogen ion H plus from the acid combined with the hydroxide ion OH minus from the base to form the water and salt.
Okay, now let's move on to the apparatus used in acid-base titration. First, we have the burette. The burette is used to hold the titrant and deliver it accurately into the flask. During titration, the solution is added slowly, usually drop by drop, so that we can determine the endpoint precisely. Next is the pipette. The pipette is used to transfer a fixed volume of the analyte solution. It is designed to provide very accurate volume measurements, which is important for obtaining reliable results. The conical flask is used to hold the analyte solution during the titration process. Its shape allows us to swirl the solution easily without the risk of spilling. We also use a volumetric flask. This apparatus is mainly used when preparing standard solutions because it allows us to make solutions with an exact and accurate volume. Lastly, we have the indicator. The indicator changes color near the endpoint of the titration, helping us identify when the acid and base have completely reacted. These apparatus work together to ensure accurate and precise titration results. Next, let's look at the four types of acid-base titration. The first type is strong acid and strong base titration. In this case, both substances completely ionize in water, producing a very sharp endpoint. A common example is hydrochloric acid or HCl reacting with sodium hydroxide (NaO). The second type is strong acid and weak base titration. Here, the acid is fully ionized, but the base is only partially ionized. Because of this, the endpoint occurs below pH 7. An example is HCl reacting with ammonia (NH3). The third type is weak acid and strong base titration. Since the acid is only partially ionized, the endpoint is usually above pH 7. A common example is acetic acid reacting with sodium hydroxide. Lastly, we have weak acid and weak base titration. In this type, both the acid and base are weak, so the pH change around the endpoint is less obvious, making it harder to determine accurately. An example is acetic acid reacting with ammonia. So, the main difference between this titration is the strength of the acid and base used, which affect the pH and the endpoint of the reaction.
So this is the most important part of acid-base titration, that is indicator that we use. Indicator is used in acid-base titration to show the endpoint of the reaction by changing their color. So this is the example of a few indicators that we use. The first one is phenolphthalein. For the acidic color is colorless and the basic color is changed to pink. And then methyl orange and methyl red, which is the same properties that for acidic color it changes to the red and basic color it changes to the yellow. And the last one is bromotyl blue, which is for the acidic color it changes to the yellow and basic color it changes to the blue. So this is the conclusion from the indicator that we use, which is strong acid plus strong base. We can use for the bromotyl blue or phenolphthalein. For the strong acid and weak base, we can choose the methyl orange and methyl red, and the weak acid plus strong base, we can choose phenolphthalein.
Okay, now I want to explain about application. This analytical method has many important applications in our daily lives and across various industries. First, in food industry, it is commonly used for vinegar analysis. This method helps determine the concentration of acetic acid, which is the main component responsible for vinegar sour taste. By measuring the acetic acid content accurately, manufacturers can ensure product quality, consistency, and compliance with food regulation. This is important because consumers expect the same taste and quality every time they purchase the product. Next, in the pharmaceutical industry, this method is widely used in quality control laboratories. It helps determine the concentration in active pharmaceutical ingredients in medicine to ensure patients receive the correct dosage. Accurate analysis is crucial because even small variation in drug concentration can affect the effectiveness and safety of the medication. Moving to water quality analysis, this method is used to evaluate the chemical properties of water, such as acidity, alkalinity, and the concentration of dissolved substance. The information obtained helps ensure the drinking water is safe and meet healthy standards. Water treatment facilities regularly perform this analysis to monitor water quality before distribution to the public. Lastly, in environmental monitoring, this method is used to analyze pollutants in rivers, lakes, industrial wastewater, and other environmental samples. The result helps scientists and environmental agencies assess pollution levels, identify contamination sources, and develop strategies to protect ecosystem and public health. Overall, this analytical method is highly valuable because it provides accurate, reliable, and cost-effective results.
In conclusion, acid-base titration is an important analytical technique used to determine the concentration of an unknown acid or base solution. The endpoint of the titration is detected using suitable indicators, which allow us to identify when neutralization has been achieved. This technique has many applications in chemistry and various industries. It provides accurate and reliable quantitative results and is considered as a simple and cost-effective method that is widely used in laboratories. However, obtaining precise results depend on the proper selection of indicators and careful experimental procedures. Therefore, understanding acid-base titration is essential for quality control, research, and chemical analysis.
I just had to let you know you're